Hello, my name is Divideep, and today we're going to be doing our third video in this video series, which is about functions. So, before we talk about functions in Python, let's generally talk about what functions are on a high level in programming. So, a function is a block of code which only runs when it's called. So far, programming-wise, what we've been doing is we've been coding with, if statements, for loops, while loops, so on and so forth. And these have all been blocks of code that when we tell the program to run, it will always run it. Unless, of course, it's a conditional loop, in which case it will only run when the condition is satisfied, so on and so forth. But regardless of whether or not the condition is satisfied, the code itself will run. Whether or not the code inside that particular loop or not will run, that's a different story, depends on the condition. But the whole program itself will run, right? But a function doesn't necessarily have that feature. In fact, it has a unique feature whereby it's a block of code which only runs when it is specifically told to. You can pass data, known as parameters, into a function. What that means is essentially, parameters are like variables. In fact, they are variables. And the reason I say they're like variables is because they can vary, but unlike a normal variable where we're just normally doing calculations where you just modify a variable and whatnot, in a parameter, you're actually passing the variable inside a function. You're passing it inside. Usually what we're doing is we're working with the variable outside, but in the case of a function, we're passing that variable value inside into the function and sort of injecting it and then working with it. And the function can return data as a result. So if we pass a certain parameter in, and you can have multiple parameters, yes, we will get into that, don't worry. But you pass that and we do whatever you want to do inside your function, which again will only run when you tell the function to by calling it, then it can return data, can have output data. So calling a function. So we've been talking about, setting the function and whatnot, that you have code inside a function, but let's actually talk about calling a function. So to create a function, we use the following syntax. Def new function. Now, again, this new function, that's a function name. So the black text after def, it's the function name. I've called a new function. You can, again, call it whatever you want. It's like a variable in that sense. It can have any particular name you want it to be. New function, in this case, with an underscore, is just an example of a function name. Inside that function, again, indenting. Note that, because if you don't indent, then Python will just assume the function is empty, even if you have typed the print statement, but it's outside the indenting. You indent it in, you have print, hello from a function. So the core function, then use a function name followed by parentheses. Like that, my function. Okay? Hello from a function. Now, I've just given two different function names here to illustrate the fact that a function can have different names. Now, of course, when you're actually calling a function, the function name you call and the function name you define has to be the same, because you're basically calling a function that doesn't exist. Obviously, you don't want that. So, what does that mean here? That means that this code we're all talking about is so important because these functions allow for only certain pieces of code to run depending on the circumstances, which is not something we can have in other cases. In other cases, if you don't have a function, you might have to maybe comment out some code, have some code run, so on and so forth. With functions, you don't have to do that. If you only want to run two functions out of four you've defined, just call two functions. Don't call the other two, and the other two won't run. That's a key benefit, for example. So, let's get to questions. Write code where, well, you can write a question if you want to for yourself, but write code where the user can input their names and favorite color and outputs them both. And write code that prints numbers from 1 to 100. So here you're probably thinking, oh, but this is pretty similar to what we did in the previous lessons. Yeah, it is. But the key distinction here, what we want you to do, is use functions. You define whatever code you'd run with a function and then call it with a function. Now, in these rudimentary tasks, do you have to use a function? No. But we're trying to get you to learn this. So now we've talked about functions in general, and we talked about parameters. But the fact of the matter is about parameters that you don't always need them, which is what we saw in the previous examples, right? Because you have def my function, and you had the brackets, you had a colon. The colon's the end key, just like in any other programming syntax, whereby it's a programming structure, you need a colon to indicate what's inside it. Okay, the colon's necessary in Python. But we didn't have anything inside the brackets because we had no parameters then, no arguments. And there's a distinction between arguments and parameters, which I'm going to come to in a bit. There is a distinction. It's a very minor distinction. In data language and programming, you can call it either one. You'll be fine. But there is a distinction. I'll get to that in a second. But for the purpose of this part, bear with me. So arguments are basically the information we pass into functions. It's sort of what you input into a function. So when you take a user input, you're inputting something. Parameters are basically the inputs of a function. whereas normal inputs are the inputs of your whole program. And these are specified after function name inside the parentheses. So what we're then doing, therefore, is actually when we create that parameter, the argument, again, make distinction very clear later, when you create that parameter inside, that is actually creating a variable. So in this case, fname, do you see fname anywhere before def my function? No, you don't. But just like in a for loop, when the I, the count-controlled variable, is created immediately when you create a for loop, fname is created immediately when you create the function. It's initialized, it's created right then. And normally, as we mentioned earlier, variables by default are defined as strings in the context of these parts. Now, you can define it as an integer. There are ways to do that, use int, str, whatnot to declare your variable data type, but that's something we can come to later. So, we do print fname plus smith. That's the part of this function. What it basically does, therefore, is depending on what you input as your fname, the first name, right, it'll print that first name with smith. So, what's code therefore inputs is fname, and output John Smith, Dave Smith, Mark Smith. Because John, Dave, and Mark are the values inputted for fname. They're the values for the fname variable. And you can add as many arguments as you want, just to separate them with commas. If you want to do first name and last name, if you didn't want to have a Smith, then you'd have to do fname, comma, lname for last name, or whatever variable name you want it to be. Just make sure you input the correct amount. And we'll come to that in a bit. So, number of arguments. A function must be called with the correct number of arguments, and the reason is very simple. If you define that to be 2 arguments, 2 parameters, again, we'll come to distinction, trust me. If you don't have the correct number of arguments, Python gets confused, and I'll explain why. If you're typing a function, you have 2 arguments, you're going to input 2 things, and you only input 1 thing, Python's wondering, hey buddy, where's the second thing? What's the second thing you're meant to input? Confused. You can't have that. That means if your function expects 2 arguments, you have to call the function with exactly 2 arguments. No more, no less. So which code will work in this case? Pause the video and think about it for a second. Okay, so the code that will work is the first one, because in the second case, we have my function, John, and then we don't have the Smith. And the reason we need the Smith is because in def my function, I've specified that to be 2 arguments, fname for first name, and lname for last name, right? And the reason we have a speech marks in the middle between fname and lname with a plus sign is to create a space, because when you're printing it, it automatically doesn't have a space. So we're just adding a space in to ensure that you have a space when you output the values into the console. And therefore that means the first code will work because we have 2 arguments being defined in the function and 2 arguments, input values being passed in to the function when it is called. So now for the moment we've been waiting for, or at least I've been waiting for, is the distinction between arguments and parameters. Okay, oops, gave you a sneak peek of the question. You didn't see that. So, arguments versus parameters. So parameter is the variable listed inside the parentheses in the function definition. And the argument is value that is sent to a function when it's called. That's all fancy speak for saying this. A parameter is the input variable. It's the variable we input into a function when we're defining it. The argument is the value for the parameter. So if my parameter in this case is fname, that's the variable. That's the variable fname. The argument is the value of the parameter. So if my parameter was, say, user number, right, then we know you want to input a user number, our argument would be 1, 2, 7, 9, 24, 25, whatever. It can be a number, right? Any integer. And what that therefore means is, the key distinction is, technically, when we're talking about calling a function, if we call the argument a parameter, we're not completely wrong, because the argument is the value of the parameter, and the argument itself is technically the parameter, because if you think about it, the parameter is the variable, the argument is the value of that variable. So technically, it's kind of the same thing, because the argument itself is linked to the parameter. It itself is the value of the parameter. So they are essentially very similar things in normal speak. But the key distinction is the argument is the value of the parameter, the value contained within the parameter, and the parameter is the value inside the function. So I think of this as a Russian dolls kind of system. So in Russian dolls, you know, you have your big doll, your small doll inside the big doll, your even smaller doll inside the small doll, so on and so forth. You have the dolls inside. So the way I think about it is this. The big doll is the function. The small doll is the parameter inside the function. And the argument is the tiniest doll inside the parameter doll, which is the medium door, the small door, whatever you want to call it. So question 1, the one I gave you a sneak peek of by accident. Write a function that can check if a number is prime. I know I've left you a little bit confused maybe there, so let me first clarify something. A prime number, to check out if a number is prime, there are complicated methods. You can search them online. But essentially, to recap, prime numbers are prime numbers that can only be divisible by itself and 1. So 2, 3, 5, 7, 11, so on and so forth. So a little bit more of an easier question. This might be recognizable if you've watched the previous video. Go watch it if you haven't already. The square number sequence is as follows. The Fibonacci sequence is as follows. 1, 4, 19, 9, 16, 25, 36. For the first one, 1, 1, 2, 3, 5, 8. And at one point, these both sequences, as I mentioned in the previous video, they overlap. So in that case, we go to work with if statements, while loops, for loops, so on and so forth, mixture of them to then find the answer. In this case, what we're doing is a very simple thing. We're using functions. So what we want you to do is streamline the code. And that's something I really want to know here to kind of sign off on this video very shortly is this. You're probably thinking, why do we need these functions? I mean, sure, we can separate our code out, but what's the real benefit? The benefit is that we can really, really very much streamline our code. Instead of just, having comments to separate a piece of code, we can have actual functions, we can have actual blocks to contain the codes that we don't necessarily always want to run. We may only want to run certain parts. In this case, we define a separate function for the square number sequence and a separate function for the Fibonacci sequence, get them to both run, and then do your work. It streamlines the code a lot. It helps with debugging, and it's just a generally very good programming technique. Do you always need it? Of course not. Sometimes it can be a hassle, in fact. It might lend to your program code to such an extent that it's unnecessary. But in cases where you really need to make a lot of distinctions, functions are so critical to note. Third question and the fourth question. So these are two last questions with an extra question at the end as a bonus that I forgot about. Third question is about Mersenne primes. So Mersenne primes, any prime number to form 2 to the power n minus 1. So 2 squared minus 1, 2 cubed minus 1, 2 to the power 5 minus 1. The n is some integer n, and although it does not need to be prime, it may be the case. So for example, some n values, the value of Mersenne prime is a prime number, for some it isn't. So it can vary. The n doesn't have to necessarily be prime, but in a lot of cases it automatically kind of is. So create a problem that inputs the n and checks if the corresponding value is prime. The corresponding value being, for a specific n value, is 2 to the power n minus 1 as Mersenne prime actually prime? Is it actually Mersenne prime? So to check if a number is Mersenne prime for a certain n value. This is a lot easier. Again, use a function for this, and that will allow you to really, really streamline your code because you're defining exactly how to check if something is Mersenne prime. So that's what you'd use the function for in this case. Second last question, question 4. Perfect number is any positive number that is equal to the sum of its positive divisors, excluding the number itself. Examples include 6, 28, 496, 8,128, so on and so forth, right? And what that means is that you have to create a program that checks whether or not an input number is perfect. So it's like the previous question, where for a certain value we're checking if the condition set, in that case it was for Mersenne prime, in this case you're checking if the number is a perfect number. You're checking if that's true for a certain input number. So again, you would have your function be to do the checking algorithm, to do for a certain input value, do the calculations, and then you call the function with a certain parameter being passed through for the input value. Last but not least for the question, this is probably my favorite question in this presentation. It's to input any number from the user. If the user presses S, the program will check if the input number is a square number. If the user presses E, the program will check if the input number is an even number. So we talked about checking about square numbers in previous questions. Even numbers again for modulus 2 equals 0. For even for modulus 2 equals 1. Then it's an odd number. So you basically have to do two functions here mainly. Check if it's square, check if it's even, pass input values, and then go from there. So that's it from me today. I hope you enjoyed this video, and stick around for our next series in this whole video series. Ta-ta.